I was joking that maybe the literature Nobel Prize will also go to ChatGPT.
If not this year, I'm sure eventually it will be. India, there are a lot of celebrities, and one of the earliest celebrityhood one can achieve by, scoring JEE-1, and you were JEE-1 in way back in 1987.
It was quite unexpected. In fact, I call myself sometimes an accidental IIT, smartness is sometimes overrated. So you have to develop judgment, you have to have stamina, you have to have a certain self-confidence, as you said, and a resilience. There'll be a lot of failures.
Both physics and chemistry Nobel Prize went to basically people who worked in AI. As a physicist, what is your reaction to what is Nobel Prize trying to do?
I liked the atmosphere. It was by the Ganga. It was like a little ashram for physics and mathematics. 13 years that I spent there. I call it sometimes like a vanvas, but it was literally we were in the middle of a little nice forest.
Rajesh, welcome to SparX. And thanks for welcoming me into ICTS. I'm at your campus right now. I find it very inspiring every time I come here. So I'm going to start with, probably you might get embarrassed a little bit. But see, India, there are a lot of celebrities. And one of the earliest, celebrityhood one can achieve by, scoring JEE-1. And you were JEE-1 in way back in 1987. So must have been quite something. And also after that, you chose to study physics and dedicate yourself, your entire career to physics. So just talk a bit about your thought process. Like, first of all, this JEE-1 stardom and also your thought process after that in committing yourself to the research in physics.
No, thanks, Mukesh. Firstly, also it's great to be on this podcast. And it's great to have you at ICTS. Very stimulating. The JEE was, it was quite unexpected. In fact, I call myself sometimes an accidental IITian because I think sometime in class 10 or something, I was clear that I wanted to study maths and physics and not engineering. And so I was looking at studying in a college in Kolkata where I was growing up in fact, I wasn't gearing for any IIT. But one of my seniors, one of my neighbors went to IIT Kanpur and talked about the physics department there and mentioned the courses and how wonderful it was, the whole atmosphere, the teachers and everything. And that made me interested. At the same time, I was hearing problems in the local colleges with the exam schedule. And there were many political problems also in the colleges. So this looked like an attractive option. So this was in class 11. And that's when I thought about IIT more seriously. And I thought it might be good to go for this physics program. But of course, as you know, the physics program, you don't need to have a very high rank. So I didn't do any coaching classes. I did some one brilliant tutorials used to be there at that time. They had a question bank, which I took especially for chemistry, which I was never very strong at. And then somehow, I guess I had been studying maths and physics on my own. I'd set myself an agenda after my class 10 itself that I would do these books and I would cover this material. And it was not necessarily JEE material. I was doing other stuff also, Feynman lectures in physics and things like higher calculus on higher dimensional calculus and vector calculus and so on. But I guess that training helped me for the IIT because I went about it in a sort of a structured, rigorous way. And since the IIT exams in those days were not multiple choice, I think that was a good thing because you had to give answers and you had to really think about the steps and write it down. I think 60% must have been problems like that. So anyway, so I was surprised, but parents were very supportive, but many other relatives and friends were wondering, why are you not going to IIT Kanpur to study computer science, which is what everyone normally does. So I told them, no, okay, just because I got a rank doesn't mean I have to do that. I wanted to study physics. I'm going to study.
So you never wavered. You were clear that you want to study physics and you basically...
I was very clear. I just went and I gave that as my preference.
Yeah, I almost wondered like who was the second rank in physics in your year. Must not have been very.
He was actually a very good physicist. Now it turns out Senthil Todadri was our professor at MIT.
Oh, amazing.
He was. We were very close friends. He was, I think, 87th that year in the JEE, and he also decided to do physics. And yeah. But IIT Kanpur physics was very. I think it was very special in those years. There were still some of the old teachers who were from the founding of the institute from the 1960s who had come back with a lot of idealism to grow physics in India and to teach. And they really mentored us, I feel, in a way which nowadays probably is much more kind of much more professional. Whereas at that time it was more like a guru shishya thing. It was people really took you under their wing. They talked with you outside classes a lot. You had chai with them. You went to their houses. And IIT Kanpur, I think, had that special feeling, which I think made a big difference to my mental evolution and growth. And the physics I learned both through my classmates as well as with the teachers there, I think, gave me a very solid foundation.
And Rajesh, you've been an outstanding scientist, as well as you have, worked with a lot of scientists, trained and mentored many of those. You think this, the way you were very clear in your late teen years that that's what you want to commit your career to, is this calling to science you think comes early in life or varies from people to people? And I guess you have to start early in some ways because the journey is also very daunting. There is so much foundation stuff that you have to accumulate before you can make any contribution at all.
Right. I think it helps to have exposure. And I was lucky, I think, that I had some friends who were interested in maths in school and also otherwise, with whom we used to do maths puzzles. We had a few books, which Martin Gardner's books on mathematical recreations. There was then George Gamow's books on physics and the Feynman lectures. So I think I was lucky. I grew up in Kolkata, I think, and I got some of that exposure early that helped. So it depends. I think there may be people who may not have had that exposure, but later in life, in college or otherwise, get that exposure and then realize that is maybe what they want to do. So it is. So I don't think it's, in that sense, age is a number, as they say. So it's, of course, you have to put in the years for that foundational work. But I really don't think it's ever too late or early in some sense. It helps, of course, to dedicate yourself from an early age to something. I think psychologically it's very kind of it's a powerful thing to do. But otherwise, I think there have been people who have studied their whole undergraduate in something else and then moved to mathematics or moved to physics. So yeah. So I feel it's there is room for many kinds of trajectories.
And this probably something to be said about the probably culture in Kolkata, because in high school days get access to Feynman lectures and George Gamow's books and so on. I think you mentioned earlier you watched the whole documentary series of Cosmos as well, right? Yeah. So I think this is probably legacy of Calcutta also, because had this intellectual heritage. Yeah. Even today, in a lot of towns in India, in high school, you will not know what these things are.
Absolutely. No, I think there was that, especially in the 80s when I was growing up. Kolkata, there were lectures. I heard Roger Penrose give a talk in the planetarium. And I even asked him a question. I was only in class 10 or 11. But
did you ever meet him later?
Yeah, I met
as a professional. Okay.
So, of course. But that was very inspiring. I had just read about Hawking, and then to see Penrose also there and asked him about some black holes. And then the Cosmos series was also held at the planetarium. So the planetarium was a very good place. I went to also some other public talks in Kolkata. There was Herman Bondi, a cosmologist, who had come and given a talk. So it is true that there was a lot of exposure.
That's incredible, yeah, because I grew up in small town Haridwar. And I used to go to Delhi also very often, and just, few years behind you. Among all the things you mentioned, the only thing I ever heard was brilliant tutorials, and which is what you will do for your coaching, etc. But I think this is amazing. I think it's a just underscores the importance of the larger environment and culture around. I think unfortunately, probably I think that intellectual tradition in Bengal has probably been somewhat on a decline. But I think it's great that you got exposed to that in your formative years.
On the plus side now, I think there's a lot of access through the internet now for the younger generation, independent of where you are. My son watches some fantastic videos on the internet, which I also get excited and watch with him. So that is there. But of course, the internet also, you have to know where to look, where to see, because there's so much out there. So one of the things, I think, knowledge curation is a very important thing. I feel, and here at ICTS, we have been trying to do some of that with the math circles, with other things, so that younger generation, despite wherever they are, they have access to some of these resources and a place where you can kind of bring together. In fact, it's interesting you mentioned this. Yesterday, someone sent me a link for a website which has scanned copies of all the Russian books that used to be available at that time, because at that time the Soviet Union used to bring out these very cheap
mere publishers,
Physics for Entertainment, Little Maths Library. I still have some of those copies, but someone actually has put a web page which has all those things with the scanned copies. And I was telling that we should actually link it from our Math Circles webpage so that people have this access and can access those kind of resources.
Yeah, I think that that history may not be very well known, but I think from what I understand in 70s, 80s, even 90s, so India and Russia were very close, and there was this whole I guess you can now call it more evangelism, where all these Russians will visit and they will go to the remotest corner to the country. I remember in 8th grade, these Russians coming to my school in Haridwar and distributing these physics books. They gave this thing called elementary physics, and it was very coveted. Only few copies, and everyone wanted their hand on. And there are a lot of story books and so on. And it was quite profound, and there's a lot of us got touched with that in some capacity.
And very high quality stuff. I mean, some of those books, I now look at those Little Maths Library, they were written by very eminent mathematicians, and Landau, the physicist, wrote Physics for Everyone series. So, yeah.
That's amazing. So before we, continue with the Rajesh, your journey, I think last few days, internet is abuzz with this Nobel Prize, which gets some attention every year. But this year, everyone's talking about it because both physics and chemistry Nobel Prize went to basically people who worked in AI. And that is just, bored from the blue. No one was expecting it or saw it coming. Right. And so as a physicist, what is your reaction to what is Nobel Prize, trying to do? It's aberration, or it's a sign of things to come?
In some ways, probably it's a sign of them adapting to the new kinds of ways in which science is going to evolve in the future. And they are realizing that probably you need to have that things are changing, and AI is playing an important role in both discovery of science as well as the techniques of understanding AI. Why it works also needs techniques from physics, mathematics, and other areas of fundamental science. So both ways, as they say, you can have AI for science and science for AI. I think there are both aspects of it, and they are going to be very important in the future. And it's sending a signal, I think, to young scientists and others that, this is what will be changing, how things will be evolving. And so the Nobel Committee has been, in general, trying to push the boundaries. Some years ago, they gave a Nobel Prize in Physics for climate change for some of the people who, the very early pioneers of climate modeling, Manabe and this German scientist. So they have been pushing these boundaries from areas which would be traditionally thought of as core physics. So I'm sure a lot of conservative people would be upset. I mean, also that, and I can sort of see that. I mean, that it's not about a physical discovery or a new this thing, but it's a kind of a thing that I think was important to send a signal out. And the chemistry one, of course, has had a deep impact in chemistry. The protein folding problem, I think, was considered like an unsolvable problem. And then it just got solved because of these techniques from DeepMind. So, and it will have a big impact. It has already had an impact. I think it'll continue to have a big impact in drug design and so many things. So it's going to change our world. And so, yeah, I think it's a very interesting development. I was joking that maybe the Literature Nobel Prize will also go to ChatGPT.
If not this year, I'm sure eventually it will. Yeah.
There'll be some program that will write a work of literature. Yes.
But yeah, it says, I mean, yeah, in some ways, AI revolution has been going on for a long time, but I think last few years it just exploded into mainstream.
Yeah.
It's starting to become integral part of our everyday life. For physics, it may still be, as you were saying earlier, maybe mediocre graduate student level, but the progress, year over year, it seems to be fairly exponential, and that will add up.
Yes, I think one should look at the slope and not the position, so to say. And the slope is growing in an exponential way. So it's something that one has to really see and view it as an opportunity, I think, and not as a threat. And I feel physicists can do so much more. I mean, there are so many questions of complex systems which, at the moment, our tools and even our computational tools are inadequate to answer, and which I think with the right kind of partnership with AI, it can enable us to do new physics, new kinds of science.
Got it, Rajesh. So going back to your study years, so that's, you were studying physics at IIT Kanpur, and later on, many prominent universities in US. At what point you felt like you got that confidence that you think you will be able to make some deep contribution in advancing the field? It's one thing to study where you feel, okay, I understand, but someone else did their work.
Correct.
But something I think I can now take this forward. Just when did the transition start to happen for you?
Yeah, you've touched upon a very important point, which I think a lot of people miss, in the sense that many people think academic success in doing exams and so on is a sort of the be-all and end-all, but scientific research and creativity is a very totally different ballgame. And the kind of talents needed are of a different nature, which include many things which are not only to do with sort of say how smart you are, and smartness is sometimes overrated. I think it is people who are often able to stay with a question, to or even before that, ask the right questions, and then stay with a question, develop a judgment of when a question you can make progress on it, and when you're just kind of banging your head against a wall. So you have to develop judgment, you have to have stamina, you have to have a certain self-confidence, as you said, and a resilience. There'll be a lot of failures because nature is not bound to answer your questions in some easy way. You have to try to find that path which can enable you to make some headway. So indeed, I mean, the transition from being a student to at the PhD level, it's a very difficult one for most people, and it was for me too. I think I had a wonderful advisor who I think mentored and worked very closely with me on the questions. I mean, the first question he gave me, I struggled with for almost a year, but nothing, it didn't pan out. But in the process, something came up which then we could take ahead, and which formed the bulk of my PhD thesis. And then I got a taste for being able to have. The first time, I think, in those works, I felt, I had an insight. It was probably a modest, small insight, but it was different from what anyone had before. So it gives you a certain empowering feeling. And I think, but still, human nature being what it is, and psychology is very difficult to fathom. You're always unsure. Okay, maybe that was a fluke. Maybe you did something, but how will you sustain this? How will you make creative breakthroughs? So this question was always there, and self-doubts are always there. I think it never totally goes away. I think, gets better over the years. But I think in my postdoctoral years, I had worked on some problem, and one of the things which I think has made some had some impact in that problem. There was one key point where two very different things just totally matched. The mathematical expressions totally matched. And that moment for me, I will never forget, because I think that was a kind of a first time I felt I had glimpsed something which is written in the book of the universe, which was something new, which was something different, non-trivial, and this thing. So at least I feel glad that even when I'm now stuck on some problem or not, I always remember at least I had the opportunity to once glimpse something which was written in the book of the universe. So.
That's very profound. What you're trying to say is, I think our understanding of, how the universe works, how it's structured, is still evolving. We know some things we don't know. In some capacity, for certain aspect of the, the way probably universe behaves, you is the first human ever to glimpse that, right? And that feeling has to be very unique. In some ways, the ultimate reward of being a scientist, right? That's what you aspire for, and being able to get there early in your career is, probably very fulfilling.
You need that belief that I can make a headway into this problem. Let me just do it. What will happen? At worst, I'll fail. But I would have tried to make a headway. So I think that's something these are the qualities of mind I feel a young researcher needs to cultivate.
Right, and I'm pretty sure you're cultivating that with a lot of younger researcher at ICTS, and we'll come to that. But you're also very fortunate, in your PhD supervisor, David Gross, eventually went on to win the Nobel Prize. And that, both at that time he won, but was his work well known? Like the people who knew even that time, including you, knew this person is, making seminal contribution to the field?
Yeah, no, David Gross, by the time I went in 1992 to Princeton, he was already one of the established figures, a world leader in his subject, because the discovery for which he got the Nobel Prize, which he got in 2004, I think, was actually done in 1973 with his first graduate student, Frank Wilczek, with whom he shared the Nobel Prize. So, in fact, once I had to introduce David at a public talk, and I said, going to Princeton and working with David was a privilege. His first student, Frank Wilczek, got Nobel Prize with him. The next student, Edward Witten, got the Fields Medal. So it was a tough act to follow. So he was known to be a wonderful mentor, which of course is universally recognized, and a great physicist. So it was a privilege to be accepted by him to be a student, I feel. And it has been a privilege all these years to have his support and his mentorship.
And you come across, every now and then in science, some people who are not themselves, prolific, but they are able to mentor a whole generation of scientists. I think Wheeler was one such person, right? He has just, or Niels Bohr in his day, again, a whole army of, quantum mechanics. So what does it take to have that, driving your own research, but in some ways, you are in your own world. When you're mentoring somebody, you have to almost put that person first. And by definition, the mentee is going to be many, many years or decades behind you. Probably difficult to keep up, but the different level of patience and caring and commitment.
Yeah. I think it is some people, the people who are very good mentors, I think see it as part of their calling, that it is their way also of contributing to science. By, in a sense, it's like a gardener planting something for, even if you may not see the fruits, you still plant it because you know that that's how you're going to nurture the earth. And similarly, the sort of soil of science, you want to nurture it with a new generation. And David has had, for instance, a sort of wonderful students who've kind of had a legacy. It creates a certain legacy of science beyond your own individual contributions. And it requires a special skill. Not everyone, I think, can do that. I think, as you said, patience, the sort of a lot of giving. You have to give of yourself without expecting necessarily something in return. So that it's the temperament of the person who which determines that. Yeah, no, I think that's one of the nice things about the science, doing science also, the human angle, that you form a community, you feel that you are all together in this quest. At some level, there is, of course, competition, and there will be all kinds of other human things as well. But at a broader level, people do see themselves as part of a larger community, and you're trying to grow that community. You're going to try to give back to that community.
And Rajesh, so I think as you were, graduating, you were kind of, there was time when, the field of physics were witnessing this, second string theory revolution. And I think you were also kind of swept away in that. So talk about the environment in 90s, where pretty much whole generation of, brightest physicists around the world, they really felt at the time that we are at the cusp of something very revolutionary. So how was, maybe there's a multiple questions, I think, in this one. One is, how was the environment like? What was your own thought process, right? And what was causing so much excitement about string theory at that time?
Yeah, it was a unique time to be at Princeton. In fact, I was there from 92 to 97, and a lot of the developments that you mentioned started around 94. And so I was very much in the thick of things. And there was a real buzz in the air. I mean, it was every week there would be new discoveries, new papers on the archive, new seminars that people would give. And Princeton was the hub where a lot of it was happening. And Ed Witten was giving this series of lectures, essentially reporting on the week's developments. And he is an absolutely lucid speaker. I think his level of lucidity is like unworldly, I would say. So it was something to learn from him and others there about what was happening. Actually, in my own case, it was a little interesting because I started off as a skeptic of string theory. And my PhD work with David Gross was actually more on quantum field theory, and which, of course, is well-established physics in some sense. But during this period and getting to learn these things, it gradually made me feel that there was something. So I approached the subject from a skeptical viewpoint, which was very healthy. And even now I tell some of my students, retain a part of skepticism in your this thing. Don't drink the Kool-Aid, so to say, totally. So it was good from that point of view to view the developments, but then you see that there is something non-trivial happening here. This is not an accident, and you are penetrating some mysteries. So it was very helpful for me to kind of rewire my thinking in some ways, and many of the things I contributed to afterwards, of course, built on some of that understanding. At that time, one didn't realize it, but in hindsight, I feel very fortunate to have been there in that.
And what was driving all that excitement? Why was scientific community for almost couple of decades super excited about the promise that string theory held?
Yeah, so I think in the string theory, as you know, has gone through several phases. The time when I went before this phase that started in 1994, string theory was already considered very promising in being able to tackle the problems of quantum gravity and also particle physics, perhaps. But it was still understood only when the strings would be almost free, meaning the strings would not interact with each other very strongly. And so it was in a kind of a limiting way that one understood the theory. Whereas what the developments of the mid-90s really told us was that string theory is a larger, more complete theory, and you can understand what happens when strings interact very strongly with each other. And the remarkable thing is that there is a description in terms of a seemingly different string theory, which is weakly interacting, or where the strings are not not interacting strongly with each other. So it unified the different string theories that people knew till then in a very complete way. And it was quite miraculous the way it happened. And so a lot of it built on some work by Ashok Sen, which was something very also at some level very empowering for someone like me. I mean, to see that Ashok Sen working in India had given one of the first clues that there was such a relation between different string theories, and in fact he gave some very concrete proof of it in the case of certain quantum field theories. And that, I think, it was very nice when you heard in the lectures of Ed Witten that Ed Witten said it was Ashok's work that really made him believe that there was this sort of symmetry, which he was initially very skeptical about.
It's quite incredible and probably not very well known. And Ashok Sen still works here at ICTS, I think, right? So for him, I think working out of Allahabad in a small institute, I think eventually you also went there, he was able to make this seminal contribution and kind of spur the field and give it a second leg, right? With Witten and a lot of other people built on afterwards.
Correct. So it was that was something very empowering, and I think and already the Indian string theory community was growing, and that, of course, ultimately is why I chose to go to Allahabad, and always I was very clear that I would go back to India and be part of the string theory effort there. But all these developments certainly helped.
So, which is second, very in somewhat unconventional decision, Rajesh. You were working with among somebody who was the leading physicist in the world. You were at Princeton. You probably wouldn't have dearth of opportunities or offers, and you could have worked in any probably place of your choice, I'm guessing in US, and you're choosing to come back to India, and that to Allahabad, which is obviously not a big city. Most people know Allahabad because of Kumbh and Sangam, and not for the string theory revolution.
Yeah, having been at Princeton and Harvard, I had seen all the good places. I knew what it was like, but I couldn't visualize myself living in the US for the rest of my life. Mm-hmm. It was, I spent almost a decade there. It was wonderful professionally and made many friends and everything. But it was like, it was more, I was always waiting to go back and make a difference here in India, because I felt, the country's taxpayers have been so generous to support you in a place like IIT, where we paid 20 rupees fees or something like that at that time, at least. And so I felt I owed to something that I can give back in that way. And Allahabad with Ashok Sen, and I liked the atmosphere. It was by the Ganga. It was like a little ashram for physics and mathematics, and 13 years that I spent there, I call it sometimes like a vanvas, but it was literally, we were in the middle of a little nice forest with birds and animals, and beside the Ganga, Yamuna. It was a different kind of existence, which I still miss actually now.
That's incredible. Nice physics string theory one was in Allahabad. But it was, I don't know, perhaps because of Ashok or India has a lot of leading, institutes, including TIFR that you are now part of. How did, Allahabad even got onto your radar? And this is HRI, Harish Chandra Research Institute. Like, what is a bit of history and, the surprise at the, in some of the prominence and being able to attract, people like yourself from US to come and dedicate, those 13, 14 years?
Actually, it has an IIT Kanpur connection in many ways. HRI earlier was a small place in a private institution called Mehta Research Institute in the city of Allahabad. But around, I think, the early 90s, the Department of Atomic Energy decided that they would kind of support it as a autonomous institute like TIFR or Saha Institute or Math Science, and make a new campus and hire people and support basic sciences, because I think in North India there weren't very many research institutes of that kind. So that was, I think, a very wise move. And they chose a very remarkable person as the director to do that. And this was none other than Professor H.S. Mani from IIT Kanpur, who was already a mentor of mine and of a lot of us as an undergraduate. And I respect him enormously. So I had visited him. He was the one who got Ashok and his wife Sumati to come and be faculty there in mid-90s, 94, I think. And so by the time 2000, and so I had visited and I liked the place very much. And of course, Ashok being there and some others as well made it attractive. And my wife also managed to get a position there. So it made a lot of sense for us. And Professor Mani had, I think, set up things in a very good way to have the institute. He had many of the right thoughts of what should be in place for for an institute to do enable good research. So I think then it was a collective venture. All of us really worked to build it. I think that those years in the 2000s and so on, we started getting more good graduate students, and many of them have now gone on to be faculty in very good places in India and abroad as well. So it felt like you are kind of pioneering something. I like to be a part of efforts which are trying to grow things. Something new is there, and there's an opportunity, and you can shape something new. That was what, in a way, in the US would not have been possible. You go to these established universities, you're a cog in the wheel. These are well set, they are smoothly running. That's very good. But here, new things are happening, and you can be a part of that.
Amazing. And then, post your HRI stint, been part of basically a foundation team here at ICTS. Can you just explain what is the idea behind ICTS? Why one more institute? We have, we'll talk about the state of Indian sciences later, but there are enough and more institutes also. What was the thought process that, we need one more institute, perhaps with a different thought process to move the agenda of fundamental sciences forward?
Yeah. So as you say, India has invested, I think, given its economic situation, especially what it was post-independence and so on, I think it has been really far-sighted in investing in some of these research institutes. But the need for ICTS, this was something, in fact, that coincidentally David Gross has been emphasizing, and which is based on the model of certain institutes that are there in the US. Like the Kavli Institute for Theoretical Physics at Santa Barbara, which was set up in the early 80s, I think. And then similarly in mathematics, the MSRI, or the Mathematical Sciences Research Institute in Berkeley, now called the Simon Laufer Institute. So there have been a few, or the Newton Institute in Cambridge. So there have been a few of these special institutes which have had a very catalytic role in the sciences in that country. So in KITP and MSRI in physics and mathematics have had a huge impact in US science and maths. And I've seen that firsthand in both the institutions, how they organize these programs or workshops to bring together the community in a certain area, and scientific breakthroughs, innovation, collaboration happens through in-person meeting, at least as of now. The most efficient way in which it can happen is when you put a lot of these people together. I think there is an inherent dynamic that is there among scientists, which is I call it the 3 C's, to challenge, to compete, and to collaborate. All three are there at the same time, and people evolve from one stage to the other. Someone tells you an idea, your first reaction is, "Oh, well, no, that can't be right." Or that, and you say, "No, that's." You try to find a hole in the argument and so on. So you challenge, and then you are trying to kind of come up with build on what they are saying, and then you may end up collaborating. This whole dynamic happens most effectively around a blackboard or over tea or coffee, so these places do that very effectively by bringing people together, so that's something in India was missing. We have these institutes, but they are scattered across the country. They have good people in many areas, but often the numbers are subcritical. So by bringing people together at a place like ICTS, one can hope for a big multiplier effect. And we are seeing that actually now. So David Gross was championing this idea, has been a champion worldwide for this idea. And I think with Spenta Wadia, the founder-director, they really brainstormed on how to bring this about. And it is to Spenta's credit that he really managed to move heaven and earth to get the campus and the center approved and the campus built, and with the right kind of initial conditions, which would enable it to be an international center, like we say in our name, which brings together people not only from India but from abroad, and but also in our case the added mandate of training young researchers. Researchers, again, the PhD students in these research institutes, they're often isolated. And that is a fact that we have to deal with. And that often means that you're a little behind. And in science, you're a little behind. That's a big handicap. You need to be on speed with the latest developments. And by having these programs where there is a component of mini lecture courses by experts, that really, I think, empowers these graduate students. They can feel that we can also work in this area. It's not a big deal. Okay, it's more difficult to learn these on your own from papers, sitting by yourself in a corner, some institute. You may not have many people to discuss it with. So building those peer groups, networks for collaboration later, these are the things that an institution like ICTS helps in. And we have now about 35, 40 such workshops every year. And we have over 3,000 people, of which maybe 1,000 are from abroad. About half of these are graduate students. So it has an enormous impact whether you measure it in terms of the papers coming out. I think every week there's 1 or 2 papers come out from just our program activities, workshop activities.
So you have this, amazing, researchers here, and very active collaboration with various Indian institutes as well as international. As you're saying, people come together here often to spar over, emerging topics and so on, which, probably informing each other. So what are some of those topics? What are the thrust of focus for ICTS today? Like, what kind of deep questions you think ICTS is helping, move forward our understanding?
Yeah, so one of the unique things about ICTS as opposed to the KITP or the MSRI is that our scope is even broader. Theoretical sciences, that's what the T and S are for, covers not only physics, but also mathematics, computer science, climate sciences, quantitative biology, many topics which are in some ways also interlinked. So, in fact, one of the advantages of having that very broad scope is that we can bring together people from across different topics and they can have these sort of transdisciplinary programs or workshops. And some of the topics we've had, you came last month when you did the podcast with Rob Myers, that was where this program on quantum information and quantum gravity. Now, quantum information and computing are ideas that computer scientists are working on, but people from condensed matter physics are working on. Quantum gravity is something string theorists are working on. So you bring together these communities, these different communities together, and sparks fly, like your name of your podcast. So that is one of the things which is very, I think, nice about having these workshops. So we have had a lot of focus on many important emerging areas, which are, we think, important to India. Machine learning and AI has been also a very important thrust area. Last year, we had Michael Jordan come here and give a set of lectures on machine learning and AI.
The basketball Michael Jordan.
Yes, the less famous Michael Jordan, but who...
I mean, Michael Jordan reinvented himself multiple times, including playing baseball. So one will never be surprised, but yeah, different one.
Yeah. This is the Michael Jordan from Berkeley. But we've had machine learning actually in so many interesting ways also coming up. We had a program on machine learning in health and disease, which brought together clinicians, medical doctors, together with people from data science about how they can work together, and machine learning can help in diagnostic tools and other things. So things which seem at first sight very far removed from fundamental science, but these are actually data scientists and people in fundamental science, but very eager to work with clinicians. And so this kind of transfer of knowledge from basic sciences to things which are maybe of wider impact, I think this is some of the things that ICTS hopes to push much more. Another area is in the climate sciences. We've had a number of programs on the Indian monsoon and others on the interaction between the atmosphere and the ocean, and so on, and we are growing our own in-house research capabilities in these areas. Because the Indian monsoon is a very complex dynamical system, which is of interest to scientists as a purely scientific question. Yet it is something which has a big impact in India. And if we can make some headway into that, that would be amazing. So in a way, ICTS believes in the idea that fundamental science ultimately can transform societies, transform our life, and that. But for that to effectively happen, there has to be a mode by which that impact comes out, happens. So bringing people together is the best way to do that, and I think that's.
And that brings me to the other question of where are we, according to, in terms of just the overall caliber as well as support of the ecosystem in terms of, Indian science's ability today to make seminal contributions. Looking from a distance, from a layperson point of view, pretty much all of our, Nobel Prizes were from pre-independence era, and couple in different fields that we got after independence of people who left India and worked somewhere else. So, and that just one, maybe, one benchmark. I'm sure life science is a lot more complicated than that. But still, where do you, for a layperson trying to understand, is Indian science making significant contribution? Are we living up to our full potential or not? And what will it take for us to get there?
Yeah, no, very important question, which I think is often on my mind. And I think we have, invested a good amount and we have these research institutes, but I think it is still subcritical. It has enabled us to make noticeable contributions, but not, I would say, at least in a systematic way, breakthrough contributions. So we are definitely helping push things, but very few. And I think there can be a handful of contributions, we can say, even post-independence, that have been, you might think of as really breakthroughs. And I call them sometimes like black swan effects. There are very individual fluctuations that happen. We need a systematized way of having breakthroughs in some ways, a way in which it becomes part of a normal process, that there's a kind of a cascade of breakthroughs, and which I feel we can do. We have people of that caliber. We can attract more people of that caliber. We can nurture more in the future generations of that caliber.
Yeah. Whose job is this? Does government need to do more? Institutes needs to look internally and think about how they function. Private citizens, private donors, who needs to help? It's not a critique, but where we are, we know we can do a lot better. So something different needs to happen. Going back to Einstein, and you keep doing same thing, expecting different results. It's not very smart.
Exactly. No, all of the above, I would say. I think at every stage we need to think fresh. So government, of course, as the major public funder of fundamental science, should continue to support it and support institutions, because it is well established amongst the development trajectories of so many countries. And we have seen not only those of the West, but newly developed countries like Korea and Japan also to some extent, that investment in basic science has a big return much later. But so even we talked about these Nobel Prizes of people like Hopfield and Hinton. They were not trying to, change the world, so to say. They were trying to understand certain things they were trying to understand a fundamental problem about neural networks, how do things learn, and so on. So the ability to ask these questions, that's very much in the domain of fundamental science. They did their work 4 decades ago, 5 decades ago, and that pays off now. So we have to have that investment, which cannot be based on what will be the returns tomorrow. So government has to, of course, do that, and private donors also can, I think, help to kind of supplement the government funding, because that little edge that private funding gives can give a flexibility, give a sort of a nimbleness to the institutions to do things which may otherwise be more difficult within the structures of public funding. And this has been the case in the US also. I think it's the private funding. The KITP runs on NSF funding, but their private donors have helped them to do a number of innovative new activities. And it cushions them against various sort of changes. So that is one aspect. On the other hand, I think the scientists' responsibility is also there. We shouldn't always think as scientists that it's the job of others to kind of do that. And we have to be firstly deliver in our science. Whatever we are doing, we should make sure that we are functioning at the benchmark shouldn't be what are we necessarily delivering to society or anything, but within the terms of what you are doing in your science, in your area, you should be aimed to be thinking out of the box, fearlessly explore new ideas and make impact. Enough people do that, statistically, there will be impact. So I think institutions need to empower their scientists to think, to take risks, to think big, not be sort of do incremental science. There is often a kind of institutional inertia in some ways, which makes people settle for incremental science. Because taking a risk, of course, getting out of your comfort zone, learning a new subject, learning new things is not, it has a certain barrier. But I think institutions need to sort of incentivize that. The culture and the environment in institutions should be one which has a buzz of, which is mentally stimulating to everyone who is there. That you feel that your job here is to come up with good ideas. That's what the taxpayer is, in a sense, supporting you. You're privileged that you're being supported to do something you enjoy, but now do it without any shackles. Yeah, so it will happen. I think we need to have that self-belief and need to be empowered. Just do it.
So it's a complex problem, I think, and but I think one has to recognize that, today, all of us in India take a lot of pride in, what is happening in the country, but we have to recognize that, one of the, among many key enablers is progress in fundamental sciences. We want advanced technology, we want strategic autonomy in a lot of areas, indigenous industries and so on. But all of that, they just don't appear from thin air. The first time when I was visiting, he gave me this copy of, 100-year-old memo, The Usefulness of Useless Things. We're going to talk about that, just to communicate the spirit of the nature of fundamental sciences, how one approaches and why that, memo continues to be relevant today.
Absolutely. Because the path from fundamental science to something that has world-changing impact is very non-linear. Quantum mechanics, we are now celebrating the 100 years of quantum mechanics. Most people probably on the street wouldn't realize that the cell phone that they are using, all of these are built on the principles of quantum mechanics. Whether they go to a hospital and do a cataract surgery with a laser, the laser uses the Bose-Einstein statistics and the Bose-Einstein principle to have light in that concentrated form. So similarly, the fiber optic cables, the MRI machines that we use, all rely on the principles of quantum mechanics. If these principles hadn't been discovered 100 years ago, our civilization would not be what it is now. The computers, the semiconductors, the chips, nothing would be there. So that is, I think, a recognition of that is very important, about the world-changing nature of some of these discoveries of science. Similarly, Alan Turing, when he was he was not trying to create a computer society. He was, or break codes or anything. He was thinking about Gödel's theorem, which was, you might think of as a very abstruse theorem about whether mathematics is a complete system, a formal system of completeness, which everything can be proved or not. He just tried to think about it in a very different operational way and came up with the idea of a Turing machine as a way to understand that question. So very bright people, they are challenged by some of these very difficult problems. And when they make a headway in these problems, suddenly new avenues open up. And this has continued to be the case. Graphene is now such a very common material which is going to revolutionize and a whole family of them. And this was found by some researchers who were just had two researchers at Manchester who have a session, I think, where they play around with things. So they were just trying to use sellotape and put it over a sheet of graphite. And when they peeled the sellotape, they found a thin layer of this graphene, and then they were curious about it. Okay, what does this thing do? And so it's just that. It's curiosity. It is the kind of thing you could do in your kitchen, but it transforms our world. This is, I think, a lesson. This usefulness of useless knowledge is a lesson that should be internalized by policymakers, politicians, bureaucrats. And of course, scientists need to convey that importance. And it has continued to be the case. Again, we can go back to, Hopfield and Hinton. And they were just playing around trying to understand neurons. So it's that curiosity-driven research, trying to understand some complex problem that often leads to these breakthroughs. And it is not possible for the person who makes that breakthrough to see all the consequences. And it's not necessary also. But those breakthroughs must be there. The society must enable them.
Yes, a lot of people have, whether they realize or not, a lot of vested interest in how science is done, understanding the fundamental nature of curiosity-driven research, and in some ways, having the whole ecosystem designed for that, but also holding the people involved, as you say, accountable also over a period of time, can create a much, much better scientific culture, which is required.
Exactly.
Culture drives a lot of things. And I mean, India has a very proud history of seminal contribution in so many areas. No matter how far back you go, there is something, there. So it's some ways been their DNA, but I think this 21st century, among other things, this is one area which deserves a lot of attention.
And I think we'll get there. We'll get there. The sooner we get there, the better. And this is where I think our active efforts collectively, all the stakeholders in this, I think need to really come together and come up with some game plans on how to get this done. And it can't happen over 5 years, maybe not even 10 years, but over 20 years, you'll see a difference, 20, 30 years. You'll see a difference. And we'll do it. Yeah, I think we just had a wonderful talk on Satyen Bose's life and his work. And George Gamow, going back, has this book called 30 Years That Shook Physics about quantum mechanics. And he has in the beginning a list of photos of all the major players, I think 15, 20 of them. There's only one non-European, and that was Satyen Bose in that list of pictures. So someone from Dhaka, a small college, he was just trying to understand something that Planck had said, and he wrote this paper. It was rejected. Then he sent it to Einstein, who immediately realized its significance. So it's amazing. We could do that in 1924. In 2024, we should be able to do so much more.
Right. I think that's a whole different story, and probably, one day we'll have a follow-up episode, Rajesh, about some of these, scientists who, without any resources, made profound contribution. I think their story should be well known, but more importantly, it can act as a catalyst and an inspiration for a lot of youngsters. But on that note, Rajesh, I just want to thank you for taking the time. I mean, I learned a lot from this conversation. It's great to talk to you every time we get an opportunity to speak. So thanks so much.
Thank you so much, Mukesh. It's wonderful to talk with you about so many different things. And I look forward to more of your podcasts.
Thank you. At SparX, we aim to bring to you stories of exponential impact. We share in-depth analysis of what goes behind success stories. If you find our conversations interesting, you can join us by subscribing to our YouTube channel. You can also listen to SparX on Spotify, Apple Podcast, or any other audio platform of your choice. If you have any suggestions on who we should invite or what topics we need to cover, just let us know in the comments. We are always listening, looking for ways to improve, and keep getting better as we go along.